Well, here we are again. We are going to look at lesson 522, Computer Simulations of Probability. And today we're talking about random number generators, and you will have the opportunity to use your ebook. There is a wonderful tool called a number generator that you will be able to use to work through the second assigned problem today. The first assigned problem I'm going to be working through with you to share a strategy or two to help you with this wonderful study of probability that we're on right now. You were asked to imagine a random number generator that produces numbers from 1 through 20. In each game below, if the stated outcome happens, player X wins. If it does not, then player Y wins. So what I went ahead and did was I looked at the games and I tried to focus in on one at a time. So that's what we're going to do now. And this game, if the prime number comes up, player X wins. So what I did was I generated a list of all the prime numbers from 0 through 20. And then what I did over here, I generated a list of numbers that were not prime. And the kind of cool thing is, if I'm generating a number over here, I've got 1, 2, 3, 4, 5, 6, 7, 8 out of 20. And I can change it to a percent if I want, but I'm going to leave it like this right now. And if it's 20 possible, if 20 is my possible total, or my total that I'm going to be working from, because it's 1 through 20, I'm going to count up what's here, or I can simply subtract 8 from 20, and I get 12 out of 20 are not prime numbers. In the second game, even numbers, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I generated all the even numbers, made a list of them right here. Made a list of them the odd numbers over here, because what I'm doing is I am thinking about the probability. It's theoretical probability. So here I've got 10 20th or 1/2, and the same thing over here. Then the next part of this is for game 3, a number not divisible by 3. And I went ahead again and listed numbers that are not divisible by 3 evenly. And then I've got the ones that are divisible by 3 over on the opposite side. Remember that 3 is always a multiple and is a number that we would list as being divisible by 3 because it meets the criteria. Over here, I've got 1, 2, 3, 4, 5, 6 out of 20. And then that would leave me with 14 out of 20 for the player X. Then moving down here, I've already done some of the background work. The theoretical probability that player X wins in game 1 is 8 out of 20. Game 2 is, we'll just leave these all in 20s. And then game 3 is 14 out of 20. Player Y winning, I'm going to go over here, would be 12 out of 20, 10 out of 20, and 6 out of 20. And continuing to analyze the games that we were given. Is each game above fair? No. If they were fair, they would have the same probability to win. And the only game that we have the same probability to win is game number 2 here. In which of the 3 games is player X most likely to win? Well, that would be the game that player X has the highest probability. And our Y would be it has the highest probability. And then in game number 1, the prime number game, if you played 40 times, how many times would you expect player X to win? Well, I can set this up as a equivalent fraction or equivalent ratio situation. And if I'm going to move from this ratio to 40 in the denominator location, I would multiply using my giant 1 that has 2's in it. And then I would expect player to win 16 times. Now remember, we're talking about theoretical probability here. And then what if I played 50 times? Again, I can set this up with 8/20 is what my theoretical probability is from up there. And I am going to put my, set this up so we've got 50 in the lower or denominator position. And because I did some figuring out a little bit earlier, I know that 20 times 2.5 or 2 5/10 equals 50. And we want to have that same thing in there. And I know that 8 times 2 is 16, and then half of 8 again is 20. So it would be 20 times.